Right, so what actually happened in the BOD analysis? Okay, in the aerobic process, okay, so you have bacteria, okay, to eat all these organic compound, okay. So bacteria, they're using organic compound for food, okay, and also for their carbon source, okay, carbon source for them to grow, okay, is called as heterotrophic bacteria. So any bacteria using organic, eating organic, enjoying organic, okay, is called as heterotrophic bacteria, will change the organic into carbon dioxide, water, and also new cells. Okay, if you have 100 kilograms, for instance, okay, 100 grams of organics matter, 1/3 of it will be converted into carbon dioxide and H2O. Okay, so if you have 100 grams, about 33 grams will be converted to carbon dioxide and water. And then another 67 grams, okay, will be converted to new cells. So this is the first steps. And then, okay, you remember that you are basically forming new cells. And some of the new cells, for example, some of the new cells are organic nitrogen. So the heterotroph bacteria will change, okay, will use this organic nitrogen, will change it into the ammonia nitrogen, like these new cells, okay? These are, as you remember, heterotrophic bacteria using organic for their energy and for their building up cells. So they will convert this organic nitrogen into the ammonical nitrogen, into this kind of new cells. So these new cells is being eaten by autotroph bacteria. So autotroph bacteria is a bacteria that don't use organic, that they are using inorganic for their energy. Okay, so they are eating this, okay, and then changes into the nitrate nitrogen. Okay, so this one is an autotroph bacteria. So there are so many processes occurring in our wastewater. So initially, the organic will be eaten by the heterotroph bacteria, and then some of the cells is converted into the organic nitrogen, and then these organic nitrogen cells will be converted to the new cells containing ammonium. Okay, this is ammonium. Okay, and this ammonium also can be eaten by autotrophic bacteria, but this one is not organic anymore. This one is inorganic, so it will use oxygen as well, but it is being converted from ammonium nitrogen into the nitrate nitrogen. Okay, so you can see there are two kinds of bacteria using oxygen. Okay, the first one, the heterotroph bacteria using organic, and then they are also using oxygen to biodegrade their compound. And then another kind of bacteria are using oxygen as well to eat the inorganic new cells. Okay, so they will have one bacteria eating organics and the other bacteria eating inorganics. They all consume oxygen. So what you will see actually, okay, instead of, this is the BOD graph, okay, actually we would like to see the graph that only referring to the organic bacteria. If I may rephrase my sentence, okay, you would like to see the BOD or the usage of oxygen that correspond to organic bacteria. So basically, you would like to see this curve, the first curve, or the curve that I am actually referring to you. If you see at the pointing mouse here, okay, so we would like to see what is the maximum amount of oxygen being used just for the carbonaceous oxygen demand, or just for the organic compound. Okay, in reality, if you measure it from experiment, you will not be seeing this graph. Okay, but you will be seeing the top graph. This is because in the degradable process, not only you will see the biodegradable of organic, but you also see the biodegradable of the inorganic compound, the ammonium new cells just now. You see, there are certain bacteria using that ammonium new cells. They will eat all the bacteria, they will use oxygen and add oxygen to that new cell to form nitrate compounds. Okay, so it is being added up. Okay, so the real reading that you will see from the experiment is not referring to the carbonaceous oxygen demand, but you will see the nitrification oxygen demand. It's higher than the real oxygen for organic. Or in other words, okay, if you are measuring BOD up to day 100, for instance, it will not be seeing this value, but it will see a higher value. And that higher value correspond to this value, the organic biodegradable biodegradation, and also the inorganic biodegradation due to the autotroph bacteria. So how do we get the maximum value of BOD? We label it as the ultimate BOD. How do you get this value? The L naught, the ultimate BOD. So we can get it from an equation, which is this. Okay? The ultimate BOD, or the BOD maximum, we think that correspond to the organic degradation is L naught, and this is how it is connected. BOD is equal to the L naught times 1 is just number, 10 is just number to the power of minus K. K is the constant, reaction rate constant, and T is the days, okay? So that is the day. So if you are using BOD 5 days, that means your T here is also 5. If you are measuring BOD 3, okay, you put the incubator for 3 days, that means your T here will be 3 days. So we would like to find out our L naught.